In this tutorial, you will see examples similar to those on homework number 13. These are not the same exact questions, but they just have different numbers. For questions 1, 2, and 3, you are asked to find the solution to a system of equations graphically. Sometimes your two equations will intersect. That means they have one solution or one point in common. Sometimes the intersections will be parallel, which means that they have no solutions in common. And sometimes the equations will overlap, which means that they have all points in common, or infinite amount of solutions. Let's take a look at question number 1 here. Y equals 2x minus 4 will be graphed in red. There are two values here in the equation. The first one, which is the coefficient, is called the rate of change, or the slope. The second one, which is the constant, is called the y-intercept, or initial value. In this case, it's a y-intercept, or where the line will cross the y-axis. The y-intercept is -4, so you can place a point at -4 on your graph. From there, you can find other points on the line or other solutions to this equation by following the rate of change. The rate of change is the coefficient, which is 2 over 1. So from this point, I'm going to travel 2 units up, 1 unit right. 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 I could also negate or make negative both of these values and still have the same exact number. 2 over 1 is the same as -2 over -1 because two negatives make a positive. So instead of going up and right, up and right, up and right, I could travel down and left, down and left, and I would still be on the same linear equation. Once I draw some of these points, I use a straight edge to connect my dots and make a straight line. I'm now going to label my equation so I know which is which. This is the line y equals 2x minus 4. Now I'm going to graph the second linear equation in blue. Notice that this equation is missing a variable. Y is equal to -2 means that all of the points have a -2 as their y coordinate. Y equals -2 is a special horizontal line. I'm going to cross the y-axis, that's this number line here, at -2. And all of my points have to have a -2 in the y-coordinate. So this gives me a horizontal line that runs from left to right, never touching the x-axis because I have no x in my equation. I have a y only, so I'm going to cross only over the y-axis, always at -2 here. You'll notice that this red dot and this blue dot are overlapping. Since these two points lie on both equations, let me label my second equation here, then that means that the answer to the system is the point +1, -2. That is the solution to the system. The graph is helpful, but it's not the answer. The answer is this point here. Question number 2. Let's graph the first one in green. X is equal to +2. That means I will only touch the x-axis, and I will touch it at +2. I only touch the x-axis, so I cannot go left or right because I'll eventually cross the x-axis. All of the coordinates of the point on this line have to have a 2 in the x position. So that means I have a special vertical line where all of the points start with x is equal to 2. Once I draw a few points, I connect them together, I draw my arrows, and I label my line. Now let's take a look at the next one. Y equals -4x plus 5. The y-intercept is 5, so I start with my point on the y-axis at 5. My rate of change is -4 over 1, so I go down 1, 2, 3, 4, and over 1 space. Down 1, 2, 3, 4, and over 1 space. Although it's hard to see, that point lies on both lines. So I can continue drawing this blue line. I can extend this blue line further here by going down 1, 2, 3, 4 over 1, labeling my line, y equals negative 4x plus 5, and then finding the solution that they have in common, right? So my line, not so good. That's why you want to use a straight edge. So when you use your straight edge here, you will connect these points exactly. So I can see that this blue dot is on the green line at a value of 2, negative 3. 2, negative 3. Let me see if I can get this line a tiny bit straighter. There we go. And a label. 4x plus 5. Alright, last one. Y equals negative 2x minus 7. I'll do this one in red. Minus 7, and I'm going to go down 2 over 1. Down 2 over 1. Brings me off the grid, so I'm going to reverse the slope. Instead of negative 2 over positive 1, which is what this says, I'm going to do positive 2 over negative 1. Notice I still have one negative sign in my rate of change. You can't change the original sign. If you switch the denominator, you switch the numerator. So instead of down and right, I'm going to go up and left. Up and left. Up and left. 2 up, 1 left. 2 up, 1 left. 2 up, 1 left. Here is my first equation. Y equals negative 2x minus 7. Alright, now the second sentence here says 2x plus y equals 5. And then you see here it says rewrite. This is not in slope-intercept form. So I can't graph it using my slope-intercept shortcut. So I need to take this 2x and I need to move it to the other side. And remember, if you switch sides, you switch signs. So my new sentence will be y equals negative 2x plus 5. So I start graphing at 5, and I go down 2 over 1, 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 etc., etc. Now you'll notice in the equation that the slopes are the same. And that is why these lines are parallel. And parallel lines have no points in common, so therefore they have no solutions. Let's take a look at the next 3 questions. Write the y equals mx plus b equation for each function. This is an mx minus y plus b equation. So I have all of the pieces, they're just not in the right order. So if I want the x to be on the other side of the equal sign, I need to use my property of equality here to move that term from the left to right by switching its sign. I get a cross out on the left, and then I bring down carefully all of the numbers that remain. So a minus 5y, an equal sign, and these two are not alike, so I write them side by side. Minus 3x and an invisible positive 10. Now in order to finish the problem, I need to get y by itself. So since this is multiplying, the inverse would be to divide every single term, by negative 5. This becomes an invisible 1. 2 negatives make a positive, but I'm going to leave it in fraction form because it doesn't make a whole number. And 10 divided by negative 5 is negative 2. So the answer is y equals 3/5 minus 2. Whoops, I forgot my x. Y equals 3/5 x minus 2. Now when you have a table, you need to follow this pattern to find the m position number, right? The m position number, the coefficient of x is m. To find that value, which is the rate of change, you need to follow this formula. So we're going to start with our y's, and we're going to take a look at the pattern here. Looks like it's increasing by 1, and the pattern of the x's look like they're increasing by 4. So therefore, in my statement, the number next to x will be this fraction here. The pattern of the y's, the pattern of the x's. So y equals 1/4 x is how the sentence begins. Now, how do I get the b? I go to my table and I look for the y-intercept. The y-intercept is the point when x is 0. So if x is 0, that's the y-intercept. So I take this number, exactly how it is, and place it at the end of my sentence. All right, the last one does not have a table and it does not have an equation, so we need to use this formula, rise over run, to find the slope. So you find the rise over run, right, the fraction in front of x, you find this by counting the space from point to point to point. It should be constant, should be the same for each one. So why don't we start here? We could start here, it doesn't matter. But I want to go from one point to another point. They could be close together, they could be farther apart. Either way, you're going to get the same answer. If I start here, which is a horizontal axis right here, is 6. If I rise up to 8, that's a change of 2. And if I run, I'm moving to the left, that's negative change of 10 to 8. Right? From 10 to 8 is 2, but I'm going negatively. So the rise is 2 and the run is negative 2. Now let's take a look at the blue triangle here, right? So if I go from this point up here, so from 6 to 10, that's a rise of 4. And if I go from 10 to 6, that's a loss of 4. So that's 4 over negative 4. But 4 over negative 4 and 2 over negative 2 are both equal to negative 1. Now how do I find the number here at the end? I go to my y-axis and find where the line crosses. That's called the Y-intercept. It crosses at 14, positive 14. Now you could certainly leave the equation like this, but a better answer would reduce this slope. 2 divided by negative 2 is negative 1. I'm going to leave the 1 invisible because I can. So this answer is good, but this answer is better. Let's turn it over to the back side. Which function has the greatest rate of change? Remember, rate of change can be found in a graph by using rise over run. It can be found in a table by finding the pattern of the y's and the pattern of the x's. And it can be found from an equation by finding the m coefficient value. So since this one is the easiest, because all you have to do is use your eyeballs, you go to the letter x, you find the coefficient, and this has a rate of change equal to 3, or 3 over 1. The table here, you need to know the pattern. So you can choose any 2 points you want, so I'll choose these 2. 0 and negative 5 is a decrease of 5, so my numerator is minus 5. 0 to 3 is an increase of 3, so my denominator is positive 3. That is the rate of change for the table. And the rate of change from a graph is found by creating a perfect corner point and counting the boxes of the rise over the run. Be sure to look at your scale. Don't just go by ones and assume that the scale goes by 1. Really look at this number line to check to see that if it's going by 1s or 10s or 2s. So let's see. To get from one point to the next perfect corner point, I go up 2 over 1. Let's see if it's constant. Up 2 over 1. Up 2 over 1. That's how I know that I did it right, because it's constantly the same. So here we go. Rate of change is 2. Rate of change is negative 5/3. And over here, rate of change is 3. So of these 3 answers, which one is the greatest? So of these 3 answers, the greatest one is this one, right? This is 2. This is negative 5/3. But this one is the largest. Now for the review section. To find the rate of change from 2 points, you simply need to calculate y minus y over x minus x. And if you have 2 points, the easiest thing to do is create a mini table that lines up your x's and y's. I'm going to take this point and move it down here. Set up my subtraction fraction and put my y minus y here and my x minus x here. Be sure that if you start with y2, you start with x2. y2 minus y1, x2 minus x1. 7 minus 3 is 4, and 4 minus 4 is 0. Although this answer is correct, it has not been finished. Anytime you have a 0 in your fraction, you must interpret it. And to interpret it means to choose whether the answer will be 0 or whether the answer is not possible and it's undefined. So if I have 4 items and I want to split them up so that there's nothing, that's impossible. I can break them into tiny pieces, but I can never have nothing. So this is what we call undefined. A 0 in the top, right? If I have nothing and I give it to 4 people, well, you all get nothing. That's fair. It's possible. Not something you'd want, but it's possible. So 0 in the numerator is 0, but a 0 in the denominator is undefined. All right, number 9. Identify the rate of change. I need to do some manipulating here to get y by itself, right? So I divide everybody by the coefficient so that my y can be alone. 4 divided by negative 3 is not a whole number, so I leave it in fraction form. 9 divided by negative 3 is negative 3. I did lots of math, but I'm only interested in one answer, and that's the rate of change, or the coefficient of x. 4 over negative 3. Do not write the x. Which of the following is not a linear equation? A linear equation has no powers, no square roots, no variables in the denominator, and no products of powers. No x's times y's. Alright, so no x's times y's. So what we're going to do now is we're going to look at all of our questions here. A, 6x squared plus 7. Looks like that one breaks our no power rule. So it has a power, that means it cannot be linear. These don't break any rules. This doesn't break any rules, and this doesn't break any rules. So the answer to number 10 is A. For numbers 11, 12, and 13, you need to answer whether the system of equations has one solution in common, every solution in common, or no solutions in common. So for number 11, they're parallel. That means they have no points in common, so they have none. Number 2, they have overlapping lines, so every single point is in common, so that is infinite solutions. And with question 13, they only touch at one point, therefore they have one solution in common.